We'll discuss different communication types. So there are different communication types in our network like unicast, broadcast, and multicast. So we'll discuss these different communication types one by one. Okay, so in an IP version 4 network, there are three types of communications. The first one is unicast. What is unicast? The process of sending a packet from one host to an individual host. So let us say we have four devices here. If you see here, we have three PCs and one printer is there. And this PC wants to print something, so it will generate the print command to this printer. So if you see the communication is between this PC and printer, the communication is one to one here, and it is known as unicast. Okay, unicast communication, you can say. So it is like you have called your friend, and the communication between you and your friend is unicast. It is one to one. Then we are having another communication type called broadcast. Broadcast is nothing but one to all. So in this example, if you see, we are having let us say it is having 200 computers. And this PC wants to send the same packet to all the devices, to all the 200 devices in your network, then it is known as broadcasting. Okay, so broadcasting is nothing but one to all. Okay, unicast means one to one. Then we are having another type of communication which is known as multicasting. So multicasting, the process of sending a packet from one host to group of hosts. So it is like one to many. It is not one to one. It is not one to all. It will send the packet or data to selected group of computers. Let us say again it is having 200 computers, but it will not send the packet to all the 200 computers. Let us say it is sending the packet to only three devices. Okay, and it is known as multicasting. And the best example of multicasting is Netflix. So Netflix is not available to everyone. You need to pay to see the videos. So when you pay, Netflix will multicast their services. They will multicast the services to their subscribers only. And the broadcasting, the best example of broadcasting is YouTube. YouTube is available to everyone. It is one to all. Okay, and there is a class D, as we have discussed. It is reserved for multicasting, and we will see what is the use of this multicasting when we discuss the routing. So for now, just remember this point. Class D is reserved for multicasting. Multicasting is sending the packet from one computer to many computers, not to all computers. Then again, okay, as we have discussed, IP addresses are having four portions, like 192.168.1.1. It is having four portions. Again, these four portions are divided into network and host portion. Okay, so these four portions are again divided into network and host portion. We will see the reason why they are divided into network and host portion. Before that, we need to understand what is network and what is host. Okay, what is network and what is host, we need to understand. In this example, we have connected four PCs. These PCs are referred to as host. Okay, and the collection of or set of these devices, it is known as network. All right. So class A is having one network portion and three host portions. Again, we will see what is the use, why these classes are divided into network and host portions. Just try to remember which class is having how many network portions and host portion. We will see why they are divided. Okay. Class B is having two network portions and two host portions. Class C is having three network portions and one host portion. Let us see why they are divided into network and host portion. Okay, so why IP addresses are divided into network and host portion? So if you want to make the communication between the devices in your LAN, they should be physically and logically connected. Okay, let us say you are having some computers. Let us say you are having 4 computers, and you want to connect these 4 computers to a LAN. You want to make the communication between all these 4 computers in your LAN. So it should fulfill 2 conditions. The first condition is physical connectivity should be there. And the second condition is logical connectivity should be there. So what is this physical connectivity? You will take the switch and you will connect the switch to these PCs with cable. Okay, this is your physical connectivity, but only physical connectivity is not enough. They should have the logical connectivity also. What is the meaning of logical connectivity? Let us try to understand. Logical connectivity means IP addresses should be from the same network. We need to configure the IP addresses to all these 4 computers, and all those IP addresses should be from the same network. Okay, what does it mean by same network? Let us try to understand. Okay, this is very important to understand. We cannot configure the IP address, okay, from any network. Okay, all the IP addresses should be from the same network. Okay, we cannot take the IP addresses randomly. So we will try to understand what does it mean by same network using this flat number example. So imagine if I tell you I am living on a in a flat number 410. What does it mean? What will you figure it out from this number? The first number is the floor number and 10 is the room number. Okay, so you will come to the fourth floor and you will search for the room or floor or the flat number 10. Okay, not room number, it is flat number. Okay, again, if I tell you I am living in a flat number 411. So you will see the first number first. Okay, you will come to the fourth floor and you will search for the flat number 11. All right. So if you see the first number of these two flats, it is same. Okay, which means both the flats are on the same floor. If you see here 410 and 511, the first number is not same, which means these two flats are not on the same floor. This flat is on fourth floor, this flat is on fifth floor. So to be on the same floor, the first number should be same. The same way, to be in the same network, as we have discussed, it should fulfill 2 conditions. The PCs should have the physical connectivity, the PC should have the logical connectivity. Logical connectivity means PCs should be configured with the IP address in the same network. Okay, so to be in the same network, the network portion should be same. Let us take the example. Let us say we have assigned the IP addresses from class A and we have assigned these two IP addresses to the to these two PCs 10.25.15.12, 10.12.15.15. So first we'll have the physical connectivity, then we'll configure the IP address from the same network. So these two IP addresses are from class A. In class A, as we have discussed, it is having one network portion, three host portion. So the network portion should be same to be in the same class. Okay. So the first number should be same to be on the same floor the same way. The network portion should be same to be in the same network. So if you see the network portion is same 1010. Okay, host portion, okay, it should be different and it is different here. And these two IP addresses are in the same network and they are forming the logical connectivity. Let us take another example. In this example again, these two IP addresses are from class A and class A is having one network portion and network portion is not same in both the IP addresses. So it is not forming the logical connectivity. These two IP addresses, they will not communicate with each other in your LAN. Let us take the class B example. Okay, so let us say we have assigned the IP addresses from class B 172.16.12.10, 172.16.15.15. Again, class B, as we have discussed, it is having two network portions. So the network portions should be same 172, 172, 16, 16. And the host portion is different. So it is forming the logical connectivity. PCs in your LAN, they will communicate with each other. And let us take another example. from class B, 170 to 172. First portion is same, but the second network portion is not same, so it is not forming the logical connectivity. Let us take the example of class C. So again, we have two IP addresses here, 192.168.1.1, 192.168.1.2. As we have discussed, class C is having three network portions and one host portion. So all these three network portions should be same. Then only they will communicate. To form the logical connectivity, network portion should be same. So 192, 192, 168, 168, 1 and 1. So all the three portions are same and it is forming the logical connectivity. They will communicate with each other. If you see another example, these two IP addresses are from again class C. Okay, and the first portion, three portions should be same. The network portion should be same. So let us see the first portion 192, 192, 168. First and second portion they are same, but the third portion is not same. Okay, they will not communicate with each other because it is not forming the logical connectivity. So you should always remember these two conditions. If you want to make the communication between two devices in your LAN, physical and logical connectivity should be there. Logical connectivity means IP should be from the same network.